Hello, Math 7. How y'all doing today? Happy Friday. Today we have a lesson, 11.8. We are going over real numbers. Some of you have talked with me about imaginary numbers, the numbers which aren't real, but we're not going to worry about that right now. The original chart that I have is garbage, so we're not going to worry about that. What you might want to do is copy this chart that I have, this one that we're going to be building together. Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines. The big boxes are 11 lines tall. Go ahead, pause the video while we're going over that. What I want to do, however, is I want to go over the table first while we are constructing it together. Okay? So again, 12 lines, and then we have the table of real numbers at the bottom. So go ahead and do that. Give yourself 12 lines here at the top of the page, and then we're going to go into the table of real numbers. But first, in this little header, this little heading box on top, we're going to put real numbers. Real numbers. That means all of these numbers here in both of these two different boxes are all real numbers. So let's see how I'm going to do this. So inside this little box, we're going to put 3 concentric circles. Let's see if I can do this just one-handed. Okay, so I've got 1. Hey, that's not bad. Then I've got my second one outside of that. Not as good, but get the idea. And then a third one here. You do want to leave space outside this third circle. So don't fill up the box all the way. Okay. It's not great, but you get the idea. In the innermost, this is our natural numbers. These are positive counting whole numbers. So here we have numbers like 1, 2, 16. So 1, 2, this is natural numbers. Let's do 3,419, right? These are just examples. These aren't the only ones, obviously 5, 7, whatever. Like there's an infinite amount of them. The next concentric circle is our whole numbers. So these are whole numbers. Whole numbers are natural numbers including 0. So again, 1, 2, 3,419, but it includes 0. It's still positive, so only positive numbers here. Let's do 12, 37, 19. How about 419? Same thing. Doesn't matter. These are just examples. The next outer circle, these are integers. We've been talking a lot about integers, and this is the definition of integers. It's whole numbers. So again, natural numbers are included in whole numbers, are included in integers, which are whole numbers including negatives, or what we could say is the opposite of natural numbers. So this will include -3, 12, negative 111, zeros involved here, 97, -5, again, etc., etc. Now, in the remaining area around this box, we have rational numbers. So again, including integers, but fractions or decimals that repeat and terminate, right? So we have 0.83 bar, we have 4/5, we have -4/5, right? 0 is involved again here. These are rational numbers. Let me put it at the bottom. Rational numbers. Again, -111, 542, a billion. Rational numbers, the thing is it's, 0.5. It's decimals that repeat. They're predictable. We can make a fraction out of that. I can make a fraction. This is a fraction, right? These are fractions. Rational numbers are repeating. Now, in this, they get a whole box all to their own. These are irrational numbers. Irrational numbers are decimals that do not repeat or terminate. We cannot make fractions out of them. Our favorite example for irrational numbers, I should write that first. Irrational numbers, our favorite is pi. Right? Pi is equivalent to 3.141, so on and so forth. Let's see, the square root of 2 is an irrational number. The square root of 5 is an irrational number. The square, let's see, 0. I think the book has this example, 0.101101110. Yeah, it's predictable, but we can't make a fraction out of it. So irrationals are decimals that do not repeat or terminate. I have some of the key examples there. If you guys at any time want to pause this video, that's a great idea. But we're going to be moving on to properties. Again, this is our last lesson of this chapter before our chapter review. Then your guys' test is next week. So this is properties. We spend a lot of time at the beginning of the year on properties. So I'm just going to show these all to you, do a brief overview. Our quiz today goes in depth on these. Remember the commutative property, that's where you change the order. The associative is where you change the grouping. You'll end up with the same answer, but it's using different properties, right? The identity is where it keeps the identity. When you add 0, it doesn't do anything. The inverse is where you add the opposite. So the inverse is you add the opposite and it equals 0. So 3 plus -3 is 0. So that's the inverse property of addition. We do have as well properties of multiplication. Now for these guys, again, we've been over these also. The commutative is where you change the order and you'll get the same answer. Associative is where you change the grouping. If it's all multiplication, you'll get to the same place. It doesn't matter. Identity is where it keeps its... Now, the identity property of multiplication is different than the identity property of addition because we're not adding 0. we're multiplying by 1. If you multiply something by 1, it's going to be itself, right? A new property that that multiplication has is the 0 property. That's where if you multiply something by 0, it equals 0. So it doesn't matter that we're multiplying 16 by the square root of 3, because we're multiplying it by 0, so it's going to equal 0. Okay. A couple other ones that we have for multiplication. The distributive property. This is where you multiply something to each term, so negative 3 times 5 plus negative 3 times 8. That's distributive. For those of you who memorized these early in the year, great, congratulations, you don't need to memorize it again. And then the inverse property here is where you multiply a number by its reciprocal. It will always equal 1 in this case. So 3/7 times 7/3 is going to equal 1. That's the inverse property, right? If we did this, we would multiply across, or we would simplify. Bink, 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 bink. And no matter what, we'd get 1. Again, reciprocal means you flip the number. Okay. Here's an example. Fill in the blank and name the property. Well, it's addition, and I'm just changing my group. So in the blank, I would put 9. And that's the associative property of addition. Okay. The second one. 8 times what is going to equal 0? Well, that's pretty simple. 8 times 0 equals 0, and that is the 0 property. Of multiplication. Okay. 1 equals 1 over the square root of 3 times what? This is a little tougher, but it's the inverse property of multiplication, because what times this is going to equal 1? Well, I know it's the square root of 3 over 1, which is the reciprocal. That's the inverse property of multiplication. Okay. I'll be back a little bit later with a video of your quiz. Any questions, comment down below or email me. Otherwise, love you guys. Bye.